Now we'll solve a small challenge. Okay, so the question goes like this: determine the filter coefficients h of n obtained by sampling hd of e power j omega is equal to e power minus j omega n minus 1 by 2 for omega greater than equal to 0, less than or equal to pi by 2, and it is equal to 0 from omega greater than pi by 2, less than or equal to pi. Okay, so for n equal to 7, this is what is given in the question. Okay, now the first step you need to understand here is what you can infer from the question. See the question: from 0 to pi by 2, from 0 to pi by 2, that is 90, it has e power minus j omega n minus 2. I'll just take it as e power j h for example. What happens when you find the magnitude of e power j h? It becomes cos h plus j sin h, right? When you take the magnitude, it is square root of cos square theta plus sin square cos square h plus sin square h, which is nothing but 1. So whenever e power j h is given, when you take the magnitude of it, it is always 1. So in our response, you'll be taking magnitude response, so it does not have any effect. Okay, so this is nothing but 1. It is basically what is implied is it is 1. Okay, it is 1. From 0 to pi by 2 it is 1, from pi by 2 to pi it is 0. Okay, so that's what the information that is given from the question. But this will have a effect in your phase response. Okay, this will have a effect in your phase response. Fine. Now what we'll do is step 1. Step 1 is first plot the frequency response. Plot the frequency response. Okay, so what we'll do is that we'll always plot from 0 to 2 pi. We'll do it from 0 to 2 pi actually. Okay, 0 to pi. So this is my pi by 2. Okay, so here it will get the exact one again. Okay, so now I'm plotting the magnitude response. It goes like this. So this is given in the question. This is the obvious part. Okay, so suppose this is from 0 to pi, you can even put it from minus pi to plus pi. You will get the another band. Okay, that's what you are putting here. Fine. Now first step is plotting the frequency response. You'll always take the full region 0 to 2 pi. You'll take the full region. Okay. Step 2. Sample the given frequency response. Okay, frequency response considering in our question n equal to 7. So we need 7 regions. You need 7 regions or 6 samples. Okay, you want to divide it into 7 parts, or that is you want to divide this entire region. You want to divide this entire region into 7 equal parts. That is what is given as n is 7. You want to divide into 7 equal parts. So it implies that you take 6 samples. Okay, so I'll take one sample at k equal to 0. I'll take one more at say 1, 2, 3, 4, 5, 6. Okay, now 1, these are all zeros magnitude, and here it is 6. Okay, so now this is divided into 7 parts. Can you see? First part, second part, third part, fourth part, fifth part, sixth part, and seventh part. So we have divided the frequency spectrum into 7 parts, which are nothing but 6 samples. Okay, now similarly you can do it for your phase spectrum as well. we'll restrict ourselves as far as the problem solving is concerned. Okay, we'll take in this way. Okay, we'll move on to the step 3. Step 3, finding theta of k. Okay, so theta of k we can easily find out. Theta of k and h of k we have to find out. H of k. Okay, so from the question I mean from what we have taken samples. So if you take, this is, I'm only taking the magnitude response. This is my magnitude response. Fine. So h of k is equal to, for k equal to 0, 1 and 6, it is 1. Okay, so it is equal to 1 for k equal to 0, 1, 6. It is equal to 0 for k equal to 2, 3, 4, 5. Okay, that you can see obviously. For 2, 3, 4, 5 it is 0. For 0, 1, 6 it is 1. Okay, now we can find out first step theta of k. Refer to the formula. N is odd. N is odd. It goes from minus n minus 1. N minus 1 is n into pi k, where k is from 0, 1 up to n minus 1 by 2. So 7 minus 1, 6 by 2, 3. For 6, 3. Okay, and it is equivalent to n minus 1 into pi. N minus 1 is you'll have 6 pi minus n minus 1 minus by n. Okay, refer to these formulas. These formulas we have given here. Okay, so you will get it as again 6 pi k by 7, where k is from 4, 5, 6, 7. Okay, we don't have 7 here. We'll restrict up to 6 because n minus 1. Okay, so the limit goes up to n minus 1. Now this is my phi value. Okay, I mean theta value. This I can further reduce to 6 pi into, if I take it as common. Okay, if I take 6 pi by 7 as common, if I take 6 pi by 7 as common, you'll get 7 minus k. 7 minus k. Okay, and now we have to find out what is my h of k. Okay, so my h of k is given as we'll take, see, even though this is full, we'll take for first half. First half means up to samples 0 to 3. You'll take samples up to 0 to 3. This will become exactly equal to that. Okay, so we'll take say third sample will be equal to 4, second sample will be equal to 5, first sample will be equal to 6, and so. Okay, so what we do is that we take only for 0 to 3, for only for 0 to 3. So for only for 0 to 3, if you consider k equal to 0, 1. Okay, 0, 1, which has a magnitude 1, it has a angle theta. This is my theta, this is my magnitude. So how do I write that? E power, the angle is 6 by 7 pi k. Okay, minus 6 by 7 pi k into j. Okay, that's how you put it for k equal to 0, 1. For k equal to 2, 3, 2, 3, the magnitude is 0. Okay, so I put it as 0. This is my h of k function. You have to take it. Now we'll go to our another formula, h of n. H of n is given as 1 by n h of 0 plus 2 times k equal to 1 to n minus 1 by 2. I'm writing the formula alone here. Okay, real part of h of k e power j 2 pi n k by n. Okay, this is a formula. For our case, n equal to 7. Okay, 1 by 7. What is h of 0? When you put k equal to 0, this is 1. 1 plus 2 times k equal to 1 to n is 7 minus 1, 6 by 2, it is 3 real part of h of k e power j 2 pi n k by 7. Okay, what is our h of k? H of k is nothing but this value, e power minus j 6 pi by 7 k. That's the value of h of k. Now rewriting the equation, 1 by 7 1 plus 2 times k equal to 1 to 3 real part of e power minus j 6 pi by 7 k e power j 2 pi n k by 7. Okay, now if you actually see, k is having values 1 2 3. In this, k equal to 1, k equal to 2 and 3, its magnitude is 0. So only for k equal to 1 you will be having values. So we can write literally 1 by 7 whole bracket 1 plus 2 times, you will have only one value, k equal to 1 alone we will have. Okay, so it is real part of e power minus j 6 pi by 7, k is 1, okay, into e power j, in this case 2 pi n, n is there, k is 1, 2 pi by 7. Okay, 2 pi by 7. Now if you actually take the common factor out, 1 plus 2 real part of e power j, I will take out 2 pi by 7 out. So in this case you will have n, in this case you will have 3, so it is n minus 3. Okay, e power j 2 pi by 7 n minus 3. So what is e power j 2 pi n minus 7 by 3? It is nothing but cos 2 pi by 7 n minus 3 plus j sin 2 pi by 7 n minus 3. So what is the real part of it? This is alone is the real part, this is the imaginary part. So we can write 1 by 7 1 plus 2 times, real part of this is nothing but cos 2 pi by 7 n minus 3. Okay, that's how you write it. Now once this equation is established, this is my h of n, you have to substitute the values and get the filter coefficients, that's all. Okay, so what you'll do is that substitute h of 0. H of 0 is nothing but 1 by 7 1 plus 2 cos 6 pi by 7, right? So n equal to 0, n equal to 0 is 6 by, cos of minus is minus, so 6 pi by 7, it comes to minus 0.11456, which is nothing but h of 6. Similarly, h of 1 is equal to you will get it as, if you solve it, 0.07928, which will be equal to h of 5. Similarly, h of 2 is equal to 0.321, it is equal to h of 4, and h of 3 will be 0.42857. okay, which means that your h of 3 will be here, your h of 2, h of 1, h of 0. okay, so here it will be h of 4, these two will be symmetric, h of 5, these two will be symmetric, h of 6, these two will be symmetric, it will be same. Okay, so in this case it is it will be having a value when n is even. when n is even, the central value will be 0, all other values will exist. Okay, so now we have got the filter coefficients. This is how you design a FIR filter design by using a frequency sampling method. Okay, thank you.